hi everyone, super excited to be here. My name is Mynah. I guess that you know that already, so it's great. So I get a sense that most of us, we understand programming languages. So what we're gonna do today, we're gonna do an introduction on what is live coding. So essentially using programming language to create music in a performance context. So it's not only music that you can create, like producing a piece, for example, like creating something that will stay. It's also using the computer as an instrument. It's using the computer as a performance instrument where you actively need to play the piece or you know, whatever musical piece you're working on. So we're gonna work on that today. It's gonna be an introduction, which I hope can give you like the fundamental kind of basics hang of it, kind of gives you like a fundamental base so that after that you're free to go on your own and explore, because at the end of it, code is really unique to each one of us, and everyone has a different way of writing code and a different way of coding. And that's the beauty of live coding, is that you can incorporate your own coding style, you can incorporate your own logic, your own way to understand things, and to use your skills into producing music that's unique to you. So this is what we're going to be doing today. The software that we're going to be using is called Sonic Pi. Did everyone install it? Did everyone have a chance to install it on the machine? Yes?
Yep.
Cool. Awesome. Everyone tried to open it, make sure that it opens fine, it's running, there's no issues on that? Okay. Amazing. No, sometimes if you run Linux, I don't know if anyone is on Linux, sometimes on Linux it can be a little bit temperamental, but otherwise it should be fine. So the first thing that we are going to do, we are going to start with some sample code. So I've already pre-written kind of a base template of not really a song, but like a musical structure of a piece that, you know, already sounds like something. We're going to go through that. We're going to understand that basic template code that is there, so that we can start understanding the language. And we're going to do that by refactoring the code. So at first the code is going to be, you know, very, very basic, and understanding that we're going to refactor, understanding a little bit more how the language works, the basic syntax of the language. And after that, we're going to build on top of that a little bit, and I'll show you how you can start having fun with it, how you can start manipulating it and having fun with it. And we'll talk a little bit more about the creative process, like what's the difference when you work with something like code instead of working with like a music production software like Ableton or something like this. So the creative aspect and the creative process is a bit different. So we'll touch on that. The language that Sonic Pi is built on is Ruby. So it's a very accessible language. You'll see like the syntax is fairly simple. It reads almost like English. I mean, for some of you that have experience in like C# or things like this. Also, if you know Python, it's very close to Python. So we're gonna be looking a little bit on that. So I'm gonna paste. Oh, I see there's a. Okay, cool. Thank you, Yoav, for mentioning. I'm gonna paste a link on in the chat, and if everyone can go to that link and just copy paste the code. So I'll be sharing my screen in a second. Right now I'm just gonna paste. So in the chat you have a link, and now here. Okay, so the link that I sent you should lead you here. Okay, So for now, what I'd like everyone to do is to take this code. Oops. Copy. And then we can go and open up Sonic Pi, which I'm going to also share on my screen here. Okay. And the code that we just copied, we are going to paste it in. So did everyone manage to do that?
Yeah.
Cool. So let's start by just taking a little tour of Sonic Pi. If this is, maybe the first time that you're opening the application. So here, everyone sees my mouse, by the way? Yes, right? You see my mouse if I move the cursor. Okay. So here you have different buffers, right, where you can write your code. Up here, you have control buttons. So if you press on the most right corner, these are all your settings. So for example, for the editor, there is a couple of profiles that you can have. You can have the light profile. You can choose to have the buttons on pro or normal mode. Like if you need to know what the buttons do, you can have the words there. But if you want to do like performance type of things, and then maybe you don't want to have the name of the buttons, then you can choose the pro version. So I usually leave it on Pro Dark. You have visuals where you can choose to show the scopes. The scopes are here. They're the sound waves once the music is going to be playing. So you can show, you can hide. You can show the logs. So if you need to print something, sometimes we're debugging something, we need to like print something to see where we are in certain values or things like this. So you can choose to show that or hide it. Audio, now some cool stuff that you can do that we're not going to touch on today, but it's good to know. You can connect external devices. You can connect MIDI devices. You can also connect devices through OSC messages, so through the network. So this is something that you can explore. And if you wanted to connect MIDI devices or things like this, you would have to go into this I/O tab here and reset the drivers probably and things like this. Okay. Here on this side, so we have the play button, the stop button, record. So if we're jamming and we're working on a piece and we're performing it and playing it, so we can record ourselves while we're doing that, which comes in handy. We can load files. We can save files. So every buffer that we write, we can save it as a file, and we can load files. Okay, so this is basic tour. Now let's take a look. Let's start by taking a look at the basic code that we have here and start understanding the basics of the language and how we can use it. I'm going to try to take like regular breaks for questions. So maybe, yeah, I'll try to take regular breaks for questions. So I'll let you know. And if you want to type along with me when I'm changing things, feel free to also type along if that's easier for you. Okay, so first thing here, so use BPM 120. So BPM, beats per minute. This is the speed that our piece is going to play. So the higher the number, the faster the speed of the piece. After that, if we look at all this code here, one thing that we see is we see that we have many loops. Everything in here is basically a loop. And specifically, we see that we have live loops. So what is a live loop? The idea of live coding is that we want to be able to modify our values while the sound is playing. So the live loop is just an extension of a regular loop. So it's just an extension of doing a basic Ruby loop that would do just this. So if I did just this and I run it, this would do an infinite loop that would just keep repeating this over and over and over again. So this is the most basic loop you can do in Ruby. Why we don't use that in the context of live coding is that it acts the way that a normal program would, which means once it starts running, it runs and you can't modify the program. So if you run it again and make a change, you're just going to have, you know, many instances of kind of the same program that's running on top of another, and it just doesn't work. So because of that, we created, or Sam Aaron, the person who created Sonic Pi, created this function that is a live loop. So live loop is an infinite loop. Whatever you put inside a live loop will always run until you stop the program. But what's special about it is that you can make changes while the code is running and run it again, and those changes will be applied as the code runs. So this is why in any kind of moment that you want to do live coding in a performance context, you don't want to just, you know, press play and let it run. You want to actually play along. We always use live loops inside of Sonic Pi because it gives you this capability. Okay, so every block of code is going to run inside a live loop. Now inside there, the only basic instructions that we need to understand to be able to make sounds and music is very simple at the base of it. It's just play and sleep. So we want to play a certain frequency and we want to wait a certain amount of time before playing something else. So that's basically the only thing that you need to understand is the concept of play and sleep, and whatever code you write is ways to kind of dynamically change these values, right? It's kind of ways to dynamically change which notes are going to be played, which frequencies are going to be played, and how long these sounds are going to wait between one another. And then we might want to put, you know, blocks of things one on top of the other. So we might want to put things that are going to run at the same time. So there's many, you know, infinite variations of things that we can do. But basically music, right, is just a question of play and sleep. So that's what's great with Sonic Pi, is that to start, you really don't need to know that many instructions. So for example, here, I've hard-coded a melody using only play and sleep. And in this case, I'm using the same value of sleep every time. Okay, so maybe let's hear it. So I'm gonna run it. I have my computer audio, so hopefully it's gonna be fine. So let me run it. Oh, sorry, I forgot that I did that. Okay, super basic code. Was everyone able to hear that kind of fine?
Yeah.
Okay. Okay. So it's nothing fancy, but I just wanted to show you that actually with, you know, very basic language, with very basic language, it's already possible to do something that sounds, you know, okay, it holds itself, you know, it makes sense, it makes musical sense. So now what we're going to do, we're going to try to refactor this a little bit. We're going to try and see exactly what's going on, see how we can optimize our code and learn more capabilities of the language in the process. So here, let's start with the drums. So because the drums are a pre-recorded sound, so all the drum sounds are samples. So instead of using the keyword play, we're going to use the keyword sample, which basically means it's the same thing. Instead of playing a MIDI sound, we want to play a sample. So the keyword is different. This is the sample that I'm playing. It's called BD Tech. The amp is the amplitude, is how loud I want the sample to be. And the cutoff, it chooses the kind of frequencies. Cutoff is, you can experiment with it later and see if you change the values and you change the numbers, how it affects the sound. It basically isolates a certain frequency and it cuts off everything that's on top of it, right? Yeah, everything that's on top of it. So in this case, it isolates the frequency at I think 60, I'm not sure if it's hertz or something like this, and everything that's above it will get cut off. So it muffles the sound a little bit. You can experiment with it.
I have a question.
Yes.
I didn't understand the sample. What is sample exactly?
A sample is a pre-recorded sound.
Ah, okay, okay.
So there's two ways to play sounds in Sonic Pi. You either play MIDI, so that's like having a keyboard that you can switch and have like different sounds, and then like you play the keys, so that's like MIDI. Or you play a sample, which is like any sound that's pre-recorded, so like drum sounds, you know, or like someone recorded a drum and then you play it back, basically. So
as pre-defined a certain length, or like is it a fixed length, or?
No, every sample has its own length. So we'll talk about that. That comes later, but we'll talk about that. So it depends on the samples that you're using. Some are really short and some are longer. Okay?
Yeah, you're right.
Awesome. So here we have our sample, which is going to be a bass drum. I sleep for 4. And you see there's different sleep values here. So this is why it creates like that beat at the bass drum. If I comment everything out and we just. Okay. Okay. So these are the sleep values that create all those stops and the beat. Let's move on to see. Okay. So here, so next loop. Oh, first we want to refactor. So let's start by refactoring. Okay, so here in this first loop, so one thing that I don't like here is that if I want to change, if I'm playing and I want to change the cutoff value and I want to change it everywhere, then I need to change each one of these numbers, which is really very annoying. We don't want to do that. So, you know, you can start adding a little bit of logic and just add variables here to simplify your life. And A for me is going to be for amplitude. C is going to be for cutoff. And just replace this everywhere. Like this, it's already much more efficient. If you're playing, then you just change the value of the variable instead of changing all the individual values. Okay, done. Next loop, we have a little hi-hat that is also part of the drum. It's a little tick, 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 tick that is playing like stable. For now, we're not going to touch it. It's the same. We're playing a sample. We're giving it a volume, which is not very loud. The rate is the speed. So how fast are you playing back a sound? So rate rate affects like the quality of the sound. So the default is going to be 1. 1 is like normal speed. If you put 0.5, it's going to be half speed. And if you put it 2, it's going to be double speed. Also, if you put it minus something, it's going to reverse the sound. So it's something like, for example, let me put another buffer here and I can illustrate it better. So let's say I have a sample, and this time I'm going to put a loop, and I'm going to say rate is 1. Okay, so if I play this, this is my loop normal. Okay, now if I do this, and here I'm probably going to have to do that. So if I put the rate 0.5, so it just slows down kind of everything. And if I put it -1, it reverses the sound, right? So rate is something that's really fun to play with. Like, it's really fun to play with different rate values. And a little bit later, I'm going to show you how to use randomness and things like that. So these kind of parameters, which affect the quality of the sound, later on, they're really fun to play with, just to add texture, to add variation, things like this. So this is the rate. Any questions for that until now? Are we good?
Yes, I have one question, please.
Yes.
The parameter that you created was inside the loop scope or outside of the loop scope?
The one that I just created, for example?
Yes.
It was in a different buffer. So this is in a different buffer.
No, I mean when you created the variable.
Yes, no, inside the loop. Inside the loop.
Does it matter if it's inside the scope or outside of the scope of the loop?
Yes, it does. So scope is again, it's something that you need to think about. So it's your design of depending what you want your variables to do. You can declare variables globally, but you'll have the same problem with scope as you have with any, programming issue, depending of the name of your variables and if you have many threads that are accessing your variable or not. It's the same concerns.
What I'm trying to understand is, because this is inside a live loop, that means that you can change it. So yes. If you declare the variables outside of the scope, does it still change inside the live loop?
It does.
Okay.
If you change the variable outside of the scope, and then inside your live loop you access that variable, yes, okay. It will change. The value will change. Yeah, so these things are interesting to play around with. You can also, one thing that's really nice that I can mention is that anything that's stored in memory works across buffers. So things like this, if you wanted to have constants, for example, if you wanted to have like paths of samples, you want to have your samples. I have like my file here for when I play, which are like all my constant variables. And you can also put functions in there.
So,
and you can
all the buffers share the same global?
Yes.
Okay.
Which is nice. So you can define a whole bunch of functions and variables in one buffer, put it in memory, run it, and then in any other buffer, you can access it and use them. So scope is really wide. You can, it's really something to think about in your design for live coding.
Okay, I have another question. I didn't understand really the concept of buffers. Sorry, I'm not a musician.
Okay. No, it's not a musician thing. So it's like an IDE. It's like basically having different text files, I guess, different text files that are open and different tabs. So if you run something in one buffer, it's gonna store it for everything. But if you also, I think if you stop, can you stop individually a buffer? Yeah, you can run individually buffers, but if you stop, it's global. So if you stop a program, it'll stop everything that's running, if I remember correctly. I'd have to test it. Does that answer your question, Romy?
Yep, thanks.
Okay. Okay, so let's go back. We were here. Okay, cool. We did this, we did this, we did that. So now let's look at this big chunk of code that looks really ugly and horrible and see what we can do to make it better. So here's another function that we didn't see. So SonicPy comes with many synthesizers that you can use. So every time that you want to change the synthesizer, the default synthesizer is sine. So again, if I go back in my test buffer, if I do play 60. So if I don't specify a synthesizer, it's going to use this synthesizer, which is a sine wave. It's a basic sine wave. If I want to choose a synthesizer, I can use the function that we saw, which is this, use synth. And if I space it, then you see you have the help that comes here. So this is all the synthesizers that you have access to inside of SonicPy. So, you know, this is just a question of trying them, hearing them, playing around with them, see how they sound, and you can play with them. Okay. So here I'm using this synth. I'm using the tri synth, and I'm playing a melody. So if let me just comment this out to just have the melody here. Okay. I'm gonna give you another link a little bit once we start jamming, if you want to understand the names of the notes. So I wrote a document where it explains a little bit like the notation of the notes. Just know that in SonicPy, there's two ways that you can play notes. You either give it a number, so an integer. No, actually, it doesn't have to be an integer. It can be any number. Or if you know a little bit of the music system, then you can use the name of the notes. So A, B, C, D, E, F, G works in SonicPy. The way that you use the name of the notes, so even if you don't know music, if you can just remember that the name of the notes are A, B, C, D, E, F, G. After that, to use them, so the notation in Ruby for what we call symbols, it always starts with a colon. Then you put the letter that represents the note. So let's say C. And the number here is how high you want that note to be. So 1 would be really, really low. And 5, 6 is like pretty high. So that's the only thing that you kind of need to remember for playing around with notes. It's like you put a colon, A, B, C, D, E, F, G, and then a number. I would say normally the numbers I use are between 2 and 5. 1 is like really, really low. Some synths you won't even hear it. And above 5, it's like really high. It can be interesting, depend what you you're working on, but in general, 3 is pretty in the middle. And I'll give you a link to a document that explains this a little bit more in detail. Also, like how to understand a little bit better the names of the notes if you don't have any musical knowledge at all. So here, instead of doing a chain of play and sleep, play and sleep, play and sleep, I only change the name of the note. I don't change the sleep time. All the parameters are the same all the time. So how can I refactor this? So there's a very handy little function, which is called play pattern timed. And it does exactly what it says that it's going to do. So you give it a pattern, you give it a list of notes, you give it a list of sleeps, and it figures out the rest for you. So we're going to give it the same list that I have here. So it's going to be C3, E3, F3, and G3, as well as the same but a bit higher. So C4, E4, F4, and G4. And I'm gonna give it another list. It's the all the sleep times that I have here. So it's just gonna be 1, 2, 3, 4, 5, 6, 7, 8. 8 times 0.5. Right. And we can take the same parameters that we had. So the same thing that we had for each note, we just need to put it 1 time. So that's gonna, these parameters are gonna affect this whole function. And once we've done that, we don't need this anymore. I'm gonna uncomment this for now.
Okay. What are you pressing to comment and uncomment?
So I'm on Mac. So for me, it's command and /. And I think on Windows, it should be, what, Alt, is it? Control, maybe? Control and /.
I'll check. Okay.
Yeah. Amir. I didn't say Amir. Hi. Okay. So this, I'm just going to get rid of it. No need anymore. Already that looks much better, right? After that, let's take a look at the parameters. So we have a couple of parameters here that are new that we didn't see. So there's 4 parameters that affect the shape of the sound. Okay, so these parameters that are going to shape the shape of the sound are attack, decay, sustain, and release. So when you just start off playing things with Sonic Pi, all these parameters have defaults already built in. You normally, like you can play without having to affect them. But there's really interesting effects that you can get by playing around the shape of the wave. So maybe you don't want a sound to come in really strong. Maybe you want something to come in like, you know, gradually. So then your attack, because attack is at the beginning of the sound, so your attack is going to be very slow, you know. Or maybe you don't want a sound to stop right away. Maybe you want it to take time to slowly fade out. So in that case, your release is going to be very large. Maybe you just want something that sustains for a really long time. So then you know, the sustained time where the sound stays on the same kind of intensity. You can put it longer, you can put it shorter, depending. So these are parameters that are really interesting to play with. Attack is the beginning of the wave. The sustain is that part of the wave where it, you know, it stays. And then the release is that part of the wave that goes back to silence. And the decay is, I guess the way that I understand it is kind of this shape, like it's like when it transitions, how drastically does it transitions to go to the release or to go to the sustain. It gives it kind of this overall shape. So these are the things that we are affecting here. So you can try to change these values and just change the numbers and see how it affects the sound. And that's the best way to understand it. It's just to test it out. It's just to test it out and see how it affects the sound. Questions on that for now? Or we're good? Seems to be good. Okay. Okay, so now let's take a look at the bass. How are we doing on time? Oh shit. We are doing, I need to speed up. Okay, so let's look at the bass. So the bass, a little bit of the same thing. We have notes that are repeating and we have all the time the same sleep amount of time. So let's take a look at different ways, another way that we can achieve the same thing with the language. So instead of using this, I could definitely use that again, the same that we did, the play pattern time. I'm just going to do something different so that we see other possibilities. I'm going to declare another variable. Let's call it note. And instead of making a regular list, I'm going to do what's called a ring. And I'm going to put all these notes that I have here that I want to play, I'm going to put them inside that ring. Okay. Here, this ring, I'm going to explain what this is in a second. So this ring, I'm going to attach a tick method on it, which I'm going to explain in a second. And here, instead of playing C2 and all this, I just need to play the note and I can get rid of this. Okay. So what's happening here? So ring is a type of list that is very handy. Ring is a list that understands inherently that it needs to go back at the beginning once it's done. So you don't have the problem of going over your index, because ring will kind of imply that it will modulo the length of the list to go back to the beginning. So it gives you that functionality out of the box. So you don't need to worry about which index you are at in the list, if that makes any sense. Okay. And tick is a counter. So tick is something that is a method that will keep counting. So if you attach tick to something, if you attach tick to a list, it understands that it always needs to keep the counter and it always needs to look at the next element, the next element, the next element. So it'll keep ticking from element to element in your list. So ring will give it the ability to go back at the beginning, and tick will make it look at each element individually. So combining those two things, I can isolate one note to play, say, well, it's going to be a list. I want this list to always to repeat. And my note is going to be each element of the list. Every time that my loop goes around, it's going to be the next element. And I'm going to play that note. And then you only have one line of code. Any questions on that? Starting to see confused faces.
The tick is still not so clear what it is doing.
Okay, let me show you. So let's say, okay, let me go to my test buffer. And I say, one second. I have it here, okay. If I tick here, sorry, I'm struggling with the windows of the Zoom and the editor. Where is my log? Oh, it's here. Okay, I don't know why I can't access my logging terminal, but okay, so tick. Tick creates a counter. So if I tick, it means that every time that the loop is going to play, this counter is going to go up 1. Okay? If I attach that counter to a list, it's going to understand that that counter is going to be attached to the index of the elements in that list. So it's going to affect the index. So it's just that, it's like a persistent counter. Think of tick as a persistent counter. It means that you can be performing, you can be playing music, and no matter how many times you run your code again, tick will keep being persistent. It will not reset to 0 unless you tell it to, unless you explicitly tell it to reset to 0. Otherwise, it will keep its persistence. So it has a partner function, which is look. So you can tick, and then you can look at where you're at, right? So normally what we would do, if you just want to also, sometimes you need to debug it, you need to understand where you are. So you would tick, and you could print look. Because if you print tick, it is going to tick again. So if you want to print the actual result of where you are, you print look. You look at the tick and you see what it is.
So if I understand, in every loop in this loop, the value inside note will be the next one in the ring. Yes. Until it gets to the end, and then it will continue from the start.
Yes.
Okay.
Yes. Yes. That is what's happening. If I had here, you can try it later, but if I had here instead of a ring, if I had here a normal list and I'm ticking, what's going to happen?
It will just start from beginning to end and will fall off, will stop.
You'll have index error. At some point you'll have index error because it's going to, yeah. So that's...
What if you played the ring without, and you don't attach the tick? What would have happened?
If you play the ring, you can also do that. So here, that will give you a list. That means that here, if I try to play that, it's going to error. because it's a list and now I'm saying to play a note, but I could do that. Oops, no. No, apparently I can't do that. Unexpected, float, literal.
I mean, you can play a specific index, like note 1, note 2. Note 3.
Yeah. This you can do, but if you want to have it, so no, you absolutely. Okay, maybe my error is not from here. What's happening?
Yeah, but I understand. Thanks. It's like tick is iterating through the list.
Yes. Sorry, guys. Just having. Oh, and then I get stressed and then I don't see it. That's always what happens. Okay, where is my, is it here? No. Close this. Unexpected float, literal. Did I... Wow, what am I not seeing? 35.
Do you have the line numbers? It's line 781.
Yeah, this is what is weird. I might have to restart it. It feels like a bug. I might have to restart it. Okay, let me just restart Sonic by just a second. Okay. Thank you for your patience, guys. It won't be long. Okay.
Mynah?
Yes, I'm done.
Thinking, maybe it's a good chance to talk for a few moments about top lab and initiative, and try
Yes.
to make
Okay.
it here in Israel. So maybe it's a good time to do it now. But one second,
Sure.
I will inform Yosef. We're starting.
I'm here.
Okay. So, yeah.
Yeah, sorry about that. I also want to get into the parts that are more fun, where we can start actually changing the music, and then you're free to go and jam. But yeah, I'd love to say a few words about Top Lap because it's something that's very dear to me. And also Eyal is there, and Eyal is a big part of the initiative as well. So what I've trying to bring to Israel, there is an organization that is called Top Lab, which is an international organization. It's not like, when I say organization, it's not like a company or something very, like this kind of, it's a community. It's more like an international community. It's been founded, I think, in 2013 or 2014. And its purpose is to promote programming as a form of performing art. So it's about anything that has to do with using programming in a context of creative expression and also in a context of performance. So when this organization was created, there was like this general community. Yes? Hello?
No, sorry.
Question?
No, sorry.
It's okay. So when this organization was created, so there was the international community, but then what happened is that most people started to do top labs in their own local communities. So a lot of different top labs started to appear around the world. There's Life Code NYC that is really big. There's Top Lab Barcelona that is doing a lot of cool stuff. There's Top Lab Mexico. There's Top Lab India. There's lots and lots of top labs everywhere in the world. And for me, it was really important to create the Israel Top Lab. So I created a group called Top Lab Israel. I've contacted the international community after the first Sonic Pi workshops that I did, meeting people like Eyal and meeting other people that were really excited about algorithms and algorithmic music. I decided to just go ahead and call our little group of 4 or 5 motivated people a community. And I wrote to the organization and I said, you know what, we are starting something here in Israel. We're small, we're tiny, but we're here and we're motivated, and there's lots of talented people in Israel, and I'm sure that this is something people would like to know about, people can have fun with. So this is the initiative. With that comes along the fact that well, I was planning an algorithm to be happening in June. Right now it's going to be canceled, but it's only going to be postponed. It will happen at some point once we know a little bit more the situation with all the pandemic. So it's also in this initiative of creating a community that also has an outlet, that we have events, we have opportunities where we can play, where we can share what we do, we can enjoy opening the box and enjoying our programming skills and our coding skills that normally are like secret, and they're like like we work behind closed doors and we code and we do all this awesome work just to hear people, like bitch about how this app is not working and that app is not working. So it's a chance to, like use programming and open the box and create that connection also with non-programmers and say like, well, actually it's a very powerful, expressive thing. Programming is a really powerful way of expression. It's a way of bringing ideas to life. So I'd love to invite you all, if this is something that sounds cool and interesting, I'd love for you to join our small little community, our small little group. You can look on Facebook, Top Lap Israel. I'll post maybe links in the chat at the end of the meeting or while everyone is jamming. And we'll keep you posted on Algoraves, other workshops. Also, if anyone has their own initiatives that they want to bring into the picture, or collaborations or anything, it's about creating a community, and it's about, you know, joining together into something that we all love doing, which is coding and playing around with code. So that's it.
Can I get some stuff, Mynah, before we continue?
Yes.
Thanks. So regarding the Top Lab and the connection to these meetings of Generative Jam,
yes.
I want to say to everybody, first of all, the people who are here for the first time, we do this meeting every week. Each time regards another program, another thing, every time another person does the workshop, and we work together. And the idea is to, like, after the Corona finishes and we want to continue on collaborating and going on forward. So if we can promote this group of people meeting here and join the Top Lab, and maybe make ourselves a real community that promotes itself, promoting ourselves together, finding collaboration worldwide, and do some stuff that also spread around the world and don't finish in our small meetings together. So it will be great. And I fell in love when Mynah told me also with Mynah, because you are so great. But also with you. And I really hope that together, all of us here and some more people probably, or hopefully, we can do make some kind of system in which we continue on the discussion between us, to learn from each other, and to create some, hopefully, some really great stuff. That's it. And last,
absolutely.
Whoever wants to get direct messages regarding this group, for example, today we didn't plan to have a password, but we did. So I just texted in the messenger group the password, and it was very easy for anyone there to see it. If you want to get direct messages in the group, in the messenger group, just write your name here if you want, or message me afterwards, and I'll connect you to this small messaging group. That's all.
Awesome. Cool. Okay, so let's go back. Let's go back. I'm going to share my screen just 1 second. Okay, so I'm going to try to speed it up because I really want to give you guys time and I want to show you more cool stuff. Okay. So here I need to write. Sorry. Okay, let's work on this one. Okay, the next thing I want to talk about is about using randomness, because one of the coolest things and the easiest things that you can do for adding like variety to your music is basically to let the computer decide for you. There is really nice ways of kind of creating using random values to generate melodies or to generate rhythms for you, or even also to affect sound parameters. So it's not necessarily to make something that's interesting. You don't necessarily need to have a lot of stuff going on, or to change a lot of notes, or to know a lot of things. A lot of the times it's just changing something in the quality of the sound. It might be even just the volume. And just putting randomness on that level can already open up a lot of possibilities. So we're going to start by doing that here. So here I have my melody. I just refactored it using a ring. And let's see if I can do something. So that's because my BPM is slow. Okay. So now the first thing that I can do, I can say, instead of tick, instead of I just want to go through, I can choose. Yes? So this is another way to do it. Instead of saying I just want to go and go through each value, I just say to the computer, choose one of them. I don't want to know which one. You go ahead. Okay. Another way that I can use randomness, let's say if I combine it with other things. First, I can also decide if I want a frequency to be played or not. So I can add conditional statements and say 1 in 2 chances, in this case, 1 or 2 chances that the sound will play. So it's kind of a true or false. It's using 1 in is like the effect of throwing a dice. Imagine you're like throwing a dice. In this case, my dice only has 2 sides, so it can only be, 1 or 2. If it's the one where the sound is going to play, it's going to play. Otherwise, it won't play. But I could also choose to have, 1 in 10. And then it would be, 1 chance in 10 that my sound will play. So I can use randomness like this. So if I just put 1 out of 2, here I go back to tick, let's say. So now it continues to go through the list, but sometimes the sound plays and sometimes it doesn't because it's 1 and 2. So the advantage of that is just the fact that 1 out of 2 times you're not playing the sound. Already that gives variation in melody, it gives variation in rhythm. So if you continue to add on that, instead of having all the time the same sleep, I can randomize the sleep. I can either say, I can do choose again. Let's say I want to choose between those 2 values. So I have a small list and I'm choosing between those 2. So then you have more variations in the rhythm. So there's a lot of combinations that you can do. You can also use, for example, if I want to go more random. So with choose, with 1 in, you're dealing with probability. You're still kind of controlling the randomness. But let's say if you want to go a bit more abstract in the randomness, for the amplitude, let's say I could use a function rrand and give it a range. So I could say between 0 and 0.7. So this is going to change the volume randomly by choosing a value anywhere from 0 to 0.7. I'm going to get rid of this right now, just so that we hear clearly. So right now you hear the volume is affected, not which note is played, but the volume is affected. You want to choose between having the note not play at all and having the note being played within a certain range of amplitude. You could always mix things and say, well, choose between 0, so the note is not playing, or anything between 5 and 9. So then this is, what is this going to give you? Well, if this is chooses that, it's just going to be the absence of the note. And if the note is playing, then you're still going to have some variation in the volume, which is nice. It helps to make it like not so static. Okay, so this is small examples just to kind of give you ideas of things that you can do. All these functions, everything is documented. That's a very important thing, actually, I didn't mention at the beginning. If you go here on the top right corner and you go on the, like not the last tab, but the one just before, on the help tab. So here you have all the, on the lang tab, you have all the language, all these functions, rand, choose, all this stuff, any function at all. Everything is documented inside SonicPy. So let's say, for example, here. Here, that's the one that we've been using. So for example, rand, and you have the documentation in here. So all the documentation, you have it built in. You also have an examples tab, which is really cool. So here you have a whole bunch of pieces that have been written by the community, which you can just take the code, paste it in a buffer, hear what it does, have fun changing the value. It's a great way to just get to know a little bit how SonicPy works and the possibilities that you have with it. So anything that I'm showing you here, you can go after that and check it in the documentation. Okay, so rand here, we saw choose, we saw if you want to choose randomly an integer. So instead of choosing a float value, if you want to choose randomly an integer, for example, let's say, we didn't see that, but yeah, it's going to be slow. But so if I use rand I, so this is an integer, and then I can give it a range between. Okay, so now it's going to sleep between 1 and 4 beats. So it's going to be very slow, the melody. Okay, so we'll see this rand I is really useful in loops, and I'll show you how in a minute. So a little bit of randomness. If we want to add on that, let's say, so remember when I said every note underneath the hood is a number. Okay, so every symbol, every variable here is a number. So if you just want the same sequence, but you just want to play it like a little bit higher or a little bit lower, you can just subtract numbers. So let's say I want to play a harmony. So I can take that, just copy that, paste it, and instead of note here, I want to play note plus, let's try 5, and let's see. Oops. Let's go back here too. I'm gonna take out the so that we hear it properly. Okay, so I'm just adding a number, and you can try which number works. Now the fun. So see here, I added conditions. So sometimes I have both of them together. Sometimes I have just one. And because it's harmonized, so it changes. So I can keep tripping on this, and I can go, you know, further and go, okay, well. So you can have fun, you know, like just fooling around, superimposing things, changing the harmony, things like this. So randomness is super fun. You can apply it to really different factors and affect in some way. So let's see another way that's for the melody. Let's see on the rhythmic side now. So let's see on the rhythm side what we can do to help us here. So we have our bass beat here. The first thing I want to do is like, I feel kind of annoyed of having this code in my way. So I want to make a function out of it. So I'm just going to cut this and I'm going to create an external function. So to define a function, I use the keyword define. I give it a name. Names are symbols, so they always start by a colon. That's a Ruby, kind of specific Ruby kind of thing. And I'm going to call that BD beat. And then the arguments go between, you know, straight lines like this. So arguments, I'm going to say, well, I want to know which drums I want. I'm going to keep my amplitude and my cutoff. Boom, and then just going to paste the same thing, and here I'm going to change that to BD. Okay. Now, here I can just use that function now. Here I can just use it. So I'm going to call it, pass it my arguments. So that's the sample I was using. That's the same one. I didn't change it. And my A value and my C value. And the other thing I want to do, so this loop is a little bit annoying. It's on its own. Like I want to have the drums together. Like I want my drum kit to be like one thing that I can kind of change and modulate. So how do I have different things going on at the same time within a same loop? So this is where threads come in. So this is where we're going to use the function in thread. So I want to have this going at the same time as this, right? So I'm going to take this, I'm going to copy it. Here, I'm going to use the function in thread do. And so in thread, what it does, it creates a block. So it creates a thread and understands that whatever block of code comes right after it, it needs to be in two separate threads. So this is how in-thread works. It creates a block of code which inherently understands that whatever comes right after needs to happen in a separate thread. Yeah, makes sense? So if I want this to happen in a separate thread, so I want this to run and I want this to run at the same time, I can take this, I can paste it here, and now I have two blocks of code. So I have my thread, which this function understands that the next block of code needs to happen at the same time, simultaneously. Okay. Does that make sense until now? No questions? Cool.
I didn't understand how the thread is closed.
With end. So everything also, that's also important. Well, should have mentioned that. Everything happens like you saw with the loops. So everything is between do and end. In Ruby, most of the time, any function or anything that you open starts with the keyword do, ends with the keyword end. So
okay, so in thread, it lets this function run and goes on without waiting for it, if I understand correctly.
Yes, it creates, like if I didn't put this, and I just played this, what would happen is that this would play. So I would hear all this. And after that would be done, I would hear this.
Okay, okay.
So if I want to have both things happen at the same time, but I don't want to have it in separate loops because they're one thing, they're kind of a unit, then that's where you use threads. So you can have multiple threads. So if you wanted to have those two things play on top of something else, then you could thread again here. And then, put another block of code there. You could go on and on like this as much as you want.
Could I have done the in-thread statement inside the function that you created?
Yes. Yes, definitely.
And what about nesting in-thread statements, like one inside the other? Does that work too?
That works. That works. The only thing you cannot nest is live loops. This you cannot nest because it doesn't make sense because it's infinite loop. So nesting an infinite loop inside infinite loop. Yep. But otherwise that works. So that's where it's fun, like go crazy in the logic. And then you can create, like some people in the examples you can see, some people have recoded like Bach minuet, or something like that, with using just logic in the structures and in the lines and in the loops. So you can go very advanced in the logic. Yeah. Okay. So if I go back, so I have my thread. I'm playing this at the same time, but now I'm going to have, something is going to happen. So if I play this, let's say maybe I play it just alone. So all of a sudden I lose my beat because I'm threading. So why is it doing that? Because this is much longer than this. So again, it's like you need to think of a little bit of arithmetic, it's like if your idea is to have this intact and this intact, then you need to calculate it in a way that the lengths are going to work. So for example, here, this whole thing is 16 beats. If you add all the sleeps together, it's going to add up to 16. So here I have a sleep 1. So how can I change that to make this thread same length as this thread? I'm just going to repeat that thing 16 times. Right? So now if I repeat 16 times this sample with a sleep of 1, it's going to end up being the same length as this which is all the sleeps together add up to 16. Okay, so if I play this now, we're back to normal. We're back to the thing that we were. So let's say I want to thread something else. Let's say I want to add some, you know, samples that are loops. So this is a pretty, oh, actually, this is a pretty popular one. So you asked me, who asked me? Was it you, Romy? You asked me for the length of samples earlier.
Yeah.
Yeah, so this is where we're at. So this loop is pretty long. I don't know what the length of it is. So if I paste this in the, let me go and test it somewhere. Okay. So if you don't know how long a sample is, you can always use this function and then pass it the name of the sample. So I want to play this sample. I'm not sure of its length. I want to make sure that I sleep long enough. So I can say, well, I'm going to sleep the time of the sample, sample duration, give it the name of the sample, and then I'm sure that, you know, it's always going to repeat and it's not going to like overlap. So this works. Yes, sorry, we're not going to do that now. So this works fine. But what happens when you're in a piece and then you want that sample to match the speed or to match the length of your thread or whatever or whatnot, and then, you know, how do you make it work together? So there's this parameter that you can use, which is called beat stretch. So beat stretch takes your sample, takes the length of it, and will squeeze it in the amounts of beats that you give it. So if I squeeze it inside 8 beats, for example, and here I'm going to just sleep 8. So it slowed it down a little bit because it's at a BPM. The default BPM is a little bit slow, so it's counting the BPMs and it's making sure that it fits within 8 beats.
So how can I cut the length of it?
So you can use start. You can start anywhere where you want, where 0 is at the beginning, 1 is the end. And you can start use finish. So here, if I finish half of the length. Right. So that plays only half of it. So you can affect the length like this. You can also change the attack, the release, things like this. But beat stretch is really handy to time it in your piece. So if you have a piece, if you have stuff that's running already at a certain speed and you want your sample to fit, most of the time you're going to use, you know, beat stretch. If you put it faster, then, so that's where also the combination part comes in, where you need to find the right samples for the right music and adjust the right speeds and, you know, see if it works, when it doesn't. Does that answer your question? Is there any more question on that, on the sample length? Okay, cool. So here, if I go back, I'm using that sample and I'm going to beat stretch it at 16 because we've established that my loop is 16 beats long, right? So I'm going to stretch it at 16, and I'm going to say 16. Okay. Okay. What you could do here is also you could use randomness. So instead of doing 16 times do, what could I say, for example? You could do could use randomness here, and you can say between 4 and, not sure if it's inclusive or exclusive, I don't remember. Maybe it's inclusive. So here I'm telling it, choose the amount of times that you want to repeat. And if you remember at the beginning, when we put the wrong amount of number of times, it was affecting our beat, right? So it was making our beat faster or slower. So with moving around things like this is how you can create effects of breaking the beat. This is how you can create effects of making interesting generated rhythmic transitions without you having to do much, because the randomness does a lot for you. So let's try. Just want to hear it with this first. So you hear how it's like affecting depending of the amount that it's choosing. So those kicks are not calculated by me. They're the effect of this loop having lengths that are changing. So if it's really shorter than here, then it's kind of going to compress the beat to speed it up. So you can play around with that, and you can create really interesting effects with that. I think that's pretty much like a good introduction of, oh, last thing, effects, because these are fun. Okay. Okay, so if you want to use effects, so for example, here on our melody, so it's just a wrapper. So this is a function that you use with effect. And the same thing that happens here. So once you hit the space, then you have the Sonic Pi help come up. And these are all the effects that you can play around with. And all of them are documented in the built-in documentation. So feel free to go and hear them, try them out. So for now, I'm going to add, for example, reverb. Each effects have their parameters also. So if you just go in the documentation, then it just shows what parameters you can use with which kind of effect. And everything, again, we wrap with the keyword end. So all the functions that are wrappers like this, it always opens with do and closes with end. So now if we mute that, you should hear that space. This is like echo kind of thing. Okay. So this is pretty much, I think this is like a lot of stuff to play around with. I think we have like around half an hour still, something like this. Is there any questions? Anything?
I have a general question about syntax.
Yes.
Seems like there are functions that have brackets and some functions have this very different style. Do you have like a rule of thumb which functions to use when? So for instance, rand is like your bracket notation.
Yes.
But do and end clauses, I find it confusing.
Okay. So yeah, this is more proper to Ruby syntax. So do and end is just it's a Ruby thing. Everything is going to be between a do and end block. There's no way around it. Ruby is a really, really permissive language. So a lot of the times you don't need to use brackets, but if you do, it's fine. It's like if you do, it's fine. If you don't, it's fine too. So it's like a bit of an annoying language for that as well, because you can see many variations of the language. But so this is standard, you know, for any block in Ruby. After that, for the syntax, arguments are going to be between like this, between pipes. And then for anything that is like a proper function, like Rn is like a function that takes a range. So again, because this is like a Ruby thing, I think that you could do, I didn't try it, but I think that you could do you know, something like that without brackets, and it would be fine. I think so. But I'm just so used to have, you know, my arguments in brackets. It's just, that's just how I'm used to do it. That, you know, I find it more clear also to see visually. So that's one thing. After that, the methods are different. So for example, so like choose is a method. So choose is a method that works on lists, for example. So then it's going to be something different. So then your list needs to have, you know, brackets. Or if you use a ring, it's a different kind of a list. So then it needs to use parentheses. And then what else? What are other times of brackets?
When you write your own functions, do you always use the way you do it, like with a do and end clause? That's how you define your own functions?
Yeah, not necessarily. You can use also def, actually. And when you use def, then the syntax is a little bit different. So if I wanted to redo that function here, so then I wouldn't use a symbol. I would just use regular name like this. And then you'd have the problem, the same issue that you can put brackets and put your arguments in there, but you don't have to. So then I would just do that, and then I would just say, you know, same. And then you don't need here to put a do. Why? I don't know. Okay, it's just one of these things. I love Ruby, but it is very, very permissive, and sometimes I prefer to have languages that restrain me more. I find it less confusing. But yeah, Ruby, there's a lot of ways that you can do things. One nice way why I like to use def more sometimes is because def allows you to use name parameters. So, you know, instead of writing it like this, like I would, you know, I could have, you know, something that would be like drum and put a default here, which is nice, you know. So depending, again, of what you're trying to build and what you're trying to do, there's lots of stuff to play with. Any other questions?
Yeah. How can I buffer my own sound?
How you can what?
Buffer my own sample.
Easy. So you just import the path. So for example, let's say you want to have your folder. So let's say, you know, sample folder is in your, you know, music samples. This is just dummy path, yeah? Like put your, it needs to be like absolute path.
Yeah.
So it needs to be absolute path. And then you can just load them. So let's say you have your samples in here and you want to have access to all the samples that are in that folder, you can just load samples. And then here, you know, whatever would be saved in that variable is a list of samples. So you could access your samples like you would any list with like an indexing like you would any list. So things like this. You could also load just one, you know, if there's only one, and then, you know, yeah.
Okay.
Yeah. So just to import the path.
Can I ask a question?
Yeah.
Can you talk a little bit about how you are preparing for to go live? What are you preparing ahead, and how much risk are you willing to take in doing stuff live, and how much is like all built in your head already before you get there? Just your process of before.
Yeah. So it really depends. It really depends on the opportunity of playing live. What I like to do, a lot of the times, I like to have at least some pre-made functions. So I really enjoy building my tools. I don't really like to start with already written code when I perform live. I like to start on a blank plate. But at the same time, I like to create my tools, and I don't see why I would have to put the audience through the pain of, you know, me typing out the whole function. Like if I have a function that I know creates a certain sound that I want to use, and that I use it in different places in my composition, a lot of the times I'll have like a little toolbox running in a different buffer that are all my function definitions. And I'll play with that, you know, during my performance. Not too much, because like if you start like just, you know, wrapping, you know, creating all those really high level functions around everything that you do, you also take out a lot of the cool stuff of the performance. So it's like kind of give and take. There's some things I know are interesting to hear the development. So when it's something that I feel, you know, it can be interesting for the audience to understand, well, this is where I'm starting, and to see and hear the process into hearing how it develops, then these are things that I'm going to code, you know, live. I'm going to do it in front of the people. But if there's things, you know, like I want a specific bass, you know, I want a specific bass sound, and I'm spending hours like tweaking like my parameters to get like that specific tone that I want, and I'm going to use it throughout the whole performance, then this is something I can definitely, you know, abstract out into its own function, and then use it in my code. Maybe I go back into not sharing the screen.
Mynah, actually, I have a screen-related question.
Okay. Okay, but 1 second. So I'll just close that. So did that answer your question more or less?
Yeah, thank you.
Cool. Yes.
I wanted to ask regarding the, I don't know, the execution buffer or the buffer you held test from. If you can just say some more stuff about it, as to how to operate it. Or...
What do you mean, the buffer that you save from?
That you test from, that you play the music from. It was 6, if I'm not mistaken.
Yeah, so the one that I'm just running examples?
Yeah.
You mean this one?
Yeah.
Yeah. So you want to understand what's going on here?
Yeah, just a little bit more to how to use it if I want to test something.
Oh, so you use it so like any other buffer. So you can just try out. So I use a lot of the times a separate buffer if I just want to hear stuff. So you can just, you know, type something like, let's hear another loop. And then listen to it.
Okay, now I understand, thank you.
Yeah, and if you don't put it in a live loop, it's gonna stop. So it's handy to just, you know, or if you want to hear like a synth, you know, and you want to hear like a specific synthesizer, hear how it sounds before you use it.
Great, thanks.
Cool.
You mentioned before that I think other people doing adaptations of classical music and different, could you maybe recommend a few sources of where to find people doing cool stuff with Sonic Pi?
Oh, well, I mean, yeah, the best source is definitely to watch what the creator does. So Sam Aaron. So he has some amazing live stream sets online. He's got some really cool DJ sets online. He has also really nice talks. So he did a lot of TED Talks and things like this where he talks about you know, just his process with it and, you know, why he came to the conclusion that he wanted to create something like this. So his name, well, you have it inside the application, but yeah, Sam Aaron. If I put it in the chat, can I stop sharing? Are we all good? Maybe I come back to camera. Yes, to see everyone. So his name is okay. Why can't I chat to everyone? Okay. Yeah, so that's his name. Besides that, well, Top Lab community, if you follow the Top Lab overall community, there's a lot of people. The live coding community internationally, super open-minded, super accessible. It's, you know, a lot of people are doing really nice stuff and they're easy to talk to. So there's a big chat on Top Lab also, where a forum where you can post questions and connect with people that are coding with all kinds of different platforms. There's not only Sonic Pi, so there's all kinds of languages, all kinds of platforms to explore. And Sonic Pi has its own forum as well, which is super helpful, and the community is super nice. So if you go on the website, you'll see a community tab and you can connect on the forum as well. Yeah, that I would definitely start there.